September 12th, 1943, Bruneval radar station, northern France. 2,300 hours. Obergefreiter Hans Müller squints through the green glow of his Freya radar scope, watching luminous dots crawl across the circular display, like mechanical insects. 3 years of radar operations have given him the instinctive ability to distinguish between genuine aircraft formations and atmospheric interference that plague the coastline equipment. Tonight feels different. The scope shows what appears to be a massive Allied bomber formation approaching from the northwest. 200 aircraft minimum, flying in perfect formation at 18,000 feet. Müller reaches for the telephone that connects directly to Luftwaffe Fighter Command headquarters in Paris. His report will trigger scramble alerts across northern France, sending every available ME 10-9 and FW 190 racing toward intercept coordinates. But the formation on Müller's scope doesn't exist. Every luminous dot represents nothing more than electromagnetic deception, a radar trick so audacious that German air defense experts would spend months trying to understand how Allied scientists had turned their most sophisticated detection equipment into instruments of strategic confusion. The technology that would blind Germany's radar network began not with military planners or intelligence agencies, but with a 34-year-old physicist named Joan Curran, standing in a cramped laboratory at the Telecommunications research establishment in Malvern, England. February morning light filtered through windows that had been painted black for security reasons, casting the cluttered workspace in artificial twilight that matched the secrecy surrounding Britain's most classified radar countermeasures program. Curran possessed the methodical precision of someone who approached electromagnetic theory through mathematical relationships rather than intuitive guesswork. Her academic background at Cambridge had provided rigorous training in wave propagation physics, but 3 years of wartime research had taught her to translate theoretical knowledge into practical weapons that could save bomber crews from German interceptors. The telephone call that would change everything had arrived the previous evening from Air Marshal Arthur Harris, commander of Bomber Command. RAF losses over Germany were becoming unsustainable. Experienced aircrew were being shot down faster than training programs could replace them. German radar-directed night fighters were achieving kill rates that threatened to end strategic bombing operations entirely. Harris needed solutions that would restore tactical advantage to Allied bomber formations, penetrating increasingly effective German air defences. The request was specific and urgent. Find a way to confuse German radar operators during the upcoming Hamburg raids. Make their scopes show formations that don't exist while hiding the bombers that do. Curran had been working on electromagnetic countermeasures for 2 years, developing theoretical frameworks for radar deception that existed primarily on blackboards covered with wave equations and frequency calculations. Her laboratory contained prototype devices that could generate radio frequency interference, but nothing tested under operational conditions against actual German radar installations. The challenge Harris presented required transforming laboratory experiments into weapons that bomber crews could deploy while flying through searchlight beams and anti-aircraft fire over heavily defended targets. The physics were straightforward in principle, but devastatingly complex in practical application. Radar systems functioned by transmitting radio pulses and measuring the time required for reflections to return from targets. German Freya and Würzburg installations operated on specific frequencies that British intelligence had identified through captured equipment and electronic surveillance. If Allied aircraft could transmit signals on identical frequencies with precise timing, they could create false echoes that would appear as genuine aircraft formations on German radar scopes. The technical requirements demanded equipment that could analyze incoming German radar pulses, calculate appropriate response timing, and transmit deceptive signals with split-second precision while operating in the hostile electromagnetic environment above enemy territory. The breakthrough came during a late-night experiment on February 15th, when Curran successfully demonstrated controlled radar deception using a modified transmitter that intercepted German radar pulses and retransmitted them with calculated delays. The laboratory setup was crude, consisting of war surplus radio equipment connected through cables that snaked across the floor like electronic spaghetti. But the oscilloscope traces showed unmistakable proof that electromagnetic deception could create multiple false targets from a single transmission source. Each delayed retransmission appeared on the receiving radar as a separate aircraft flying at distances determined by the delay timing. Squadron leader Derek Jackson arrived at Malvern the following morning carrying operational requirements that would test whether Curran's laboratory discoveries could survive the brutal realities of combat deployment. Jackson had flown bombing missions over Germany and understood the lethal efficiency of radar-directed German night fighters. His combat experience provided essential context for engineering decisions about equipment that would operate under conditions where mechanical failure meant death for entire bomber crews. The specifications were unforgiving. Any radar deception device had to function reliably at temperatures ranging from ground-level heat to 30,000-foot cold. It had to operate continuously for 8 hours while subjected to vibration, electrical interference, and potential combat damage. Most critically, it had to be simple enough for exhausted aircrew to operate correctly during night missions when split-second decisions determined survival. The first operational prototype emerged from Curran's laboratory on March 3, 1943. The device resembled a large radio receiver with additional transmitting circuits housed in a metal case designed to fit in a bomber's navigation compartment. Operation required minimal crew training. German radar pulses were automatically detected and analysed by circuits that calculated appropriate delay timing for retransmission. The operator simply activated the system and monitored indicator lights that confirmed proper function. Each delayed retransmission created false radar echoes that appeared as additional aircraft flying in formation with a genuine bomber. A single aircraft could generate radar signatures for an entire Phantom squadron. The mathematics behind the deception were elegantly simple. German radar operators calculated aircraft distance by measuring the time required for transmitted pulses to travel to targets and return as reflections. If an Allied aircraft received a German radar pulse and retransmitted it after a calculated delay, the delayed signal would register on German scopes as a reflection from an aircraft flying at whatever distance the delayed timing specified. Multiple delays could create multiple Phantom aircraft, transforming a single bomber into an apparent formation that would trigger German fighter responses against targets that existed only as electromagnetic illusions. Testing began immediately at RAF Defford, where captured German radar equipment provided realistic evaluation of countermeasures' effectiveness under controlled conditions. Flight Lieutenant Michael Bentine piloted the modified Wellington bomber that carried Curran's prototype device on its first operational trial. The aircraft took off into overcast skies that provided natural concealment, while electronic systems generated phantom formations across German radar frequencies. Ground-based monitoring equipment confirmed that the deception device was creating multiple false targets that appeared genuine to German radar operators who lacked knowledge of Allied countermeasures capabilities. The tactical implications became apparent during detailed analysis of test results. German radar-directed night fighters relied on ground controllers who guided interceptors toward bomber formations based on radar tracking data. If that tracking data included phantom formations, German fighters would waste fuel and time pursuing electromagnetic ghosts, while genuine bombers reached their targets with reduced interference. The deception would be most effective when coordinated across multiple aircraft to create large phantom formations that would overwhelm German air defense responses with too many apparent targets to engage effectively. The system that would soon earn the codename window was ready for operational deployment against Germany's most heavily defended targets. As spring 1943 progressed towards summer, Bomber Command prepared for operations that would test whether British scientific innovation could overcome German radar technology through strategic deception rather than brute force electronic jamming. The operational trials that would validate Joan Curran's radar deception technology began on April 17, 1943, when Squadron Leader Jackson climbed into the cockpit of Wellington bomber serial number HE239 at RAF Defford, carrying equipment that represented 3 months of frantic engineering refinement. The prototype device had been miniaturized from laboratory bench setup to aircraft portable package weighing 47 pounds, small enough to fit in the navigator's compartment without compromising crew operations or aircraft performance. Behind him, Flight Sergeant Robert Mills operated the electromagnetic deception system with procedures that had been rehearsed until they became mechanical routine. The target for this crucial test was a German Freya radar installation at Ostend, identified through intelligence intercepts as a critical node in the coastal defence network that guided Luftwaffe night fighters toward Allied bomber formations. British WWII service listening posts had been monitoring German radio traffic for months, recording the precise frequencies and timing patterns that characterised enemy radar operations. Tonight's mission would determine whether laboratory theory could deceive actual German operators under realistic combat conditions. Mills activated the deception transmitter as the Wellington crossed the English Channel at 12,000 feet, immediately beginning analysis of German radar pulses that swept across the aircraft every few seconds. The device automatically calculated delay timings that would position Phantom aircraft at strategic distances from the genuine bomber, creating an apparent formation of 6 aircraft flying in loose combat spread. German radar operators at Ostend would see multiple targets where only one existed, each Phantom bomber appearing authentic in every electromagnetic characteristic except physical reality. The interception began exactly as British intelligence had predicted. Luftwaffe Fighter Control vectored 2 Me-110 night fighters toward what their ground radar portrayed as a significant bomber formation approaching Belgian airspace. German pilots received detailed intercept instructions based on radar tracking data that included 5 Phantom aircraft generated by Mills' transmitter. The night fighters climbed to intercept altitude and began pursuit patterns that would lead them toward electromagnetic illusions, while the genuine Wellington continued undetected along a different flight path. Ground monitoring stations across southern England recorded German radio communications throughout the engagement, providing real-time confirmation that radar deception was achieving tactical objectives. The Me-110 crews reported visual contact with multiple aircraft that existed only as delayed radio reflections, confirming that German airborne radar was equally susceptible to electronic countermeasures. Fighter controllers directed increasingly desperate search patterns as their targets appeared to maneuver in ways that defied aerodynamic logic, splitting and reforming in response to retransmission timing variations. Jackson maintained strict radio silence throughout the mission, understanding that any transmission could compromise the test by revealing Allied countermeasures capabilities to German electronic surveillance. The Wellington flew a predetermined course that maximized electromagnetic deception effectiveness while minimizing exposure to actual German defenses. Success would be measured not by bomb damage or tactical engagement, but by the degree to which German air defense responses validated theoretical predictions about radar deception under operational conditions. The mission concluded after 3 hours with German fighters still pursuing Phantom formations that had led them progressively farther from actual Allied flight paths. Post-mission analysis of intercepted communications revealed complete German confusion about bomber numbers, locations, and intentions. Radar operators reported conflicting target data that defied conventional interpretation, while fighter controllers struggled to coordinate intercepts against formations that appeared to violate basic principles of aircraft performance and tactical behavior. Flight Sergeant Mills documented system performance throughout the mission with meticulous precision, recording power consumption, signal strength variations, and equipment reliability data that would inform production decisions for operational deployment. The prototype device had functioned flawlessly under actual combat conditions, generating electromagnetic deceptions that proved indistinguishable from genuine aircraft reflections to German radar operators who possessed no knowledge of Allied countermeasures development. The strategic implications became apparent during intelligence assessment meetings that followed the successful Ostend trial. German air defense effectiveness depended on radar-directed fighter intercepts that required accurate target tracking from detection through engagement. If Allied bombers could systematically corrupt German radar data with phantom formations, the entire night fighter system would collapse under the weight of false information that overwhelmed operator capacity to distinguish genuine threats from electromagnetic deceptions. Production orders for operational radar deception equipment arrived at Malvern within 48 hours of Jackson's mission report. The Telecommunications research establishment transformed from experimental laboratory into manufacturing facility as engineers refined prototype designs for mass production under wartime industrial constraints. Each operational unit required precision electronic components that were manufactured to tolerances measured in microseconds, creating supply chain challenges that tested British industrial capacity under resource limitations imposed by global warfare. The device that emerged from accelerated production carried the official designation Type 91 Special Equipment, though aircrew would soon know it by the more evocative codename Window Installation required minimal aircraft modification, with the transmitter unit mounted in the navigator's compartment and antenna arrays integrated into existing radio systems. Operation demanded no specialized training beyond basic procedural familiarity, allowing rapid deployment across bomber command squadrons without extensive retraining programs that would delay operational implementation. Technical Sergeant William Hayes supervised window installation across RAF Firestorm, where 106 Squadron prepared for the first large-scale operational deployment of British radar countermeasures against German air defences. His pre-war experience with commercial radio equipment provided practical expertise that bridged the gap between laboratory engineering and field maintenance requirements under combat conditions. Each installation required precise calibration to ensure proper frequency response and timing accuracy that would generate convincing radar deceptions. The aircrew briefings that accompanied window deployment revealed the revolutionary nature of electronic warfare that was emerging from scientific laboratories to challenge traditional concepts of air combat. Wing Commander Guy Gibson addressed assembled bomber crews with characteristic directness, explaining how their aircraft would soon carry equipment capable of creating phantom formations that would confuse German radar operators and reduce interception effectiveness. The technology represented a fundamental shift from defensive measures that merely protected individual aircraft toward offensive systems that actively degraded enemy capabilities. Flight engineer Thomas Mitchell listened to technical explanations with the practical skepticism of someone who understood that complex equipment failed at the worst possible moments during combat operations. His mechanical experience encompassed aircraft systems that ranged from simple hydraulic controls to sophisticated navigation instruments, but window represented entirely new technology that operated according to electromagnetic principles rather than mechanical relationships. The device had to function reliably while subjected to temperature extremes, vibration, electrical interference, and potential battle damage that could destroy delicate electronic circuits. The mathematical precision required for effective radar deception created operational challenges that extended beyond equipment reliability into tactical coordination across entire bomber formations. Window effectiveness would be maximized when multiple aircraft generated complementary phantom formations that created overwhelming target complexity for German radar operators. Coordination required precise timing and frequency management that would prevent mutual interference between Allied countermeasures while maintaining deceptive effectiveness against enemy detection systems. As June 1943 approached, Bomber Command prepared for Operation Gomorrah, the sustained assault on Hamburg that would test whether British radar countermeasures could achieve strategic objectives through electromagnetic deception rather than conventional bombing accuracy. The Hamburg operation briefing took place on July 23, 1943, in a converted aircraft hangar at RAF Waterbeach, where 200 aircrew gathered around intelligence officers who carried maps marked with red circles that represented the most heavily defended industrial target in northern Germany. Air Commodore Sidney Bufton stood before assembled bomber crews whose collective experience represented 3 years of increasingly costly missions over enemy territory. Tonight would be different. Tonight, British science would wage electromagnetic warfare against German technology, using weapons that existed as radio waves rather than high explosive ordnance. The target selection reflected strategic priorities that extended beyond conventional bombing objectives into experimental validation of radar countermeasures under maximum stress conditions. Hamburg possessed the most sophisticated air defense network in Europe, with multiple Freya and Würzburg installations coordinated through centralized fighter control that had achieved devastating effectiveness against previous Allied raids. German radar operators at Hamburg had guided night fighters to intercept rates exceeding 40% during recent months, creating losses that threatened to end strategic bombing operations unless countermeasures could restore tactical balance. Flight Lieutenant David Shannon examined the window equipment mounted in his Lancaster's navigator compartment with the methodical attention of someone who understood that unfamiliar technology could become lethal liability under combat stress. The Type 91 device appeared deceptively simple, resembling an enlarged radio receiver with additional transmitting circuits housed in standard aircraft equipment rack. Operation required minimal crew interaction beyond initial activation and periodic monitoring of indicator lights that confirmed proper system function throughout the mission duration. The electromagnetic warfare doctrine that had emerged from months of theoretical development and operational testing demanded precise coordination across bomber formations to achieve maximum deceptive effectiveness. Each aircraft would generate phantom formations that appeared as genuine radar targets to German operators who lacked knowledge of Allied countermeasures capabilities. Multiple bombers operating window systems simultaneously would create target complexity that overwhelmed German fighter control capacity to coordinate effective intercepts against formations that mixed genuine aircraft with electromagnetic phantoms. Navigator Flight Sergeant James Murphy studied technical procedures that transform radio theory into combat operations requiring split-second timing accuracy. The window system automatically analysed incoming German radar pulses, calculated appropriate delay intervals, and retransmitted signals that would register as aircraft reflections at predetermined distances from the genuine bomber. Each delayed transmission created phantom aircraft flying in formation with the actual Lancaster, multiplying apparent bomber strength while confusing German tracking systems that relied on consistent radar signature patterns. The departure from RAF bases across eastern England began at 21:47 hours as 791 bombers lifted into summer darkness carrying electromagnetic weapons alongside conventional ordnance loads. The formation represented the largest concentration of radar countermeasures equipment ever deployed operationally, with window-equipped aircraft distributed throughout bomber streams to maximize deceptive coverage. German radar operators would encounter phantom formations beginning the moment Allied aircraft crossed the North Sea, creating confusion that would escalate systematically as electromagnetic deception accumulated across multiple detection frequencies. Obergefreiter Müller had returned to duty at Bruneval after recovering from appendicitis that had hospitalized him during the previous month's radar operations. His experience with Freya equipment encompassed 2 years of tracking Allied formations across approaches to German-occupied territory, developing intuitive understanding of radar signature characteristics that distinguish genuine aircraft from atmospheric interference or equipment malfunctions. Tonight's display showed formations that defied conventional interpretation, with aircraft appearing and disappearing in patterns that contradicted fundamental principles of aerodynamics and tactical flight behavior. The first window activations began as bomber formations crossed coordinate lines that marked German radar coverage zones, immediately corrupting tracking data with phantom aircraft that multiplied apparent Allied strength by factors that overwhelmed operator capacity for accurate assessment. Müller watched his scope register formations that appeared to contain hundreds of bombers flying in impossible configurations, splitting into multiple groups that reformed in geometric patterns that no human pilot could execute under combat conditions while maintaining coordinated flight discipline. The telephone calls to fighter control headquarters reflected escalating confusion as radar operators across northern France reported conflicting data about Allied bomber strength, composition, and flight paths. Luftwaffe controllers attempted to coordinate intercepts based on tracking information that contradicted basic assumptions about aircraft performance and tactical behaviour. Night fighters received vectors toward phantom formations that led interceptors away from genuine bombers while consuming fuel and time that reduced overall defensive effectiveness. Major Klaus Hermann commanded the Night Fighter Gruppe, responsible for Hamburg's air defence, operating from bases equipped with the most sophisticated radar-guided intercept systems available to German forces. His pilots had achieved remarkable success rates against previous Allied raids through tactics that relied on ground-controlled intercepts, directed by radar operators who provided precise target location data. Tonight's operations began with radar reports that suggested the largest Allied formation ever assembled for strategic bombing, creating target opportunities that should have resulted in devastating interception rates. The Me-110 night fighters that scrambled from Stade and Vector airfields carried airborne radar systems that complemented ground-based tracking, providing pilots with independent target acquisition capability once ground controllers established initial intercept vectors. Flight crews expected to encounter dense bomber formations that would provide multiple engagement opportunities throughout the approach to Hamburg. Instead, they found electromagnetic chaos that rendered both ground-based and airborne radar systems unreliable for tactical coordination. Hauptmann Werner Hoffmann piloted Me-110 serial number 4 U+BH into airspace that his ground controllers described as containing massive bomber formations approaching Hamburg from multiple directions simultaneously. His Liechtenstein airborne radar showed targets that appeared and vanished without warning, creating approach vectors that led toward empty sky where electromagnetic phantoms dissolved into radio frequency noise. 3 separate intercept attempts resulted in visual contact with nothing except darkness and distant searchlight beams that swept futilely across vacant airspace. The cascade failure of German air defence systems began with radar operators who could no longer distinguish genuine aircraft from phantom formations generated by window transmitters operating across multiple frequencies simultaneously. Fighter controllers lost situational awareness as tracking data became increasingly corrupted by electromagnetic deceptions that multiplied apparent targets beyond human capacity for tactical assessment. Night fighter pilots received conflicting vectors that led them through pursuit patterns designed for aircraft that existed only as delayed radio reflections. Flight Sergeant Murphy monitored window system performance throughout the approach to Hamburg, documenting electromagnetic countermeasures' effectiveness through measurements that would inform future operational deployment. His equipment generated phantom formations that registered on German radar as authentic bomber signatures, creating tactical deception that allowed genuine aircraft to penetrate air defences that had been systematically blinded by their own detection systems, turned against them through scientific precision and strategic innovation. The psychological impact on German radar operators became apparent through intercepted communications that revealed growing confusion and operational stress as familiar procedures failed to produce reliable results. Muller's voice carried increasing tension as he reported radar contacts that behaved in ways that contradicted his 2 years of operational experience. Equipment that had functioned reliably for months suddenly provided data that seemed to indicate equipment malfunction or atmospheric interference on unprecedented scales. The Hamburg raid that followed would demonstrate whether electromagnetic warfare could achieve strategic objectives through scientific innovation rather than conventional military force, testing British radar countermeasures against Germany's most sophisticated air defence network under conditions that would determine the future direction of aerial warfare. The bombing of Hamburg began at 00:57 hours on July 24th as the first Pathfinder aircraft released target indicators over the city centre, marking aiming points with cascading flares that transformed the industrial landscape into a geometric pattern of reference lights for following bomber waves. Below, German searchlight batteries swept desperately across empty sky while radar-directed flak guns fired at phantom formations that existed only as electromagnetic reflections generated by window transmitters operating with mechanical precision throughout the Allied bomber stream. Obergefreiter Franz Weber operated the master plotting table at Hamburg Fighter Control, attempting to coordinate defensive responses based on radar data that defied every principle of tactical assessment he had learned during 3 years of air defense operations. His plotting board showed Allied formations that appeared to stretch from the North Sea to the Rhine, with aircraft densities that exceeded the total bomber strength that intelligence estimates suggested the Allies possessed. The mathematical impossibility of the radar picture forced him to question whether German detection equipment was experiencing systematic failure across multiple installations simultaneously. The electromagnetic chaos reached its peak intensity as 791 genuine bombers mixed with thousands of phantom aircraft generated by window systems operating across the entire frequency spectrum that German radar installations used for target tracking. Major Hermann received situation reports from subordinate units that painted contradictory pictures of Allied strength and intentions, with some operators reporting formations of 200 aircraft, while others tracked single bombers that multiplied into squadron-sized phantoms whenever their window transmitters activated. Flight Lieutenant Shannon maintained steady course toward Hamburg, while Flight Sergeant Murphy monitored window performance through indicator lights that confirmed continuous electromagnetic deception throughout the penetration of German airspace. The Lancaster flew through searchlight beams that swept blindly across the formation, illuminating empty air while genuine bombers remained invisible to ground observers whose radar-directed targeting systems had been systematically corrupted by British countermeasures operating with scientific precision. The cascade failure of German night fighter effectiveness became apparent as Me-110 crews reported visual contact with aircraft that vanished the moment pilots attempted engagement approaches. Hauptmann Hoffmann described the tactical situation in radio reports that revealed complete breakdown of coordinated air defense, with interceptors scattered across northern Germany, pursuing electromagnetic ghosts, while genuine bombers approached their targets with minimal opposition from fighters that had been led away from effective intercept positions. The bombing accuracy that resulted from reduced German interference exceeded all previous strategic bombing operations, as aircrew concentrated on navigation and target identification, rather than evasive maneuvering against radar-directed fighters. Pathfinder flares marked aiming points with precision that allowed following bomber waves to concentrate high explosive and incendiary ordnance across specific industrial targets, rather than scattering loads across wide areas to avoid predicted flak concentrations. The firestorm that developed over Hamburg's residential districts resulted from concentrated incendiary bombing that achieved unprecedented density due to reduced German defensive effectiveness. Window-generated confusion had prevented fighter controllers from coordinating intercepts that would have disrupted bomber formations and degraded bombing accuracy through defensive maneuvering requirements. The electromagnetic deception had transformed tactical air defense from effective deterrent into ineffective response system that consumed resources without preventing strategic bombing success. Weber's plotting table registered the systematic withdrawal of German night fighters as fuel exhaustion forced individual aircraft to return to base without achieving meaningful intercepts against Allied formations that had penetrated Hamburg's air defences through electromagnetic deception rather than overwhelming force. The night that had begun with radar contact suggesting the largest Allied raid in aviation history concluded with German fighters landing at scattered airfields across northern Germany, their crews reporting tactical confusion that defied conventional explanation. The post-mission intelligence assessment that followed Operation Gomorrah revealed complete success for British radar countermeasures under maximum stress conditions against Germany's most sophisticated air defense network. Window systems had functioned flawlessly throughout the mission duration, generating phantom formations that overwhelmed German operator capacity, while genuine bombers achieved unprecedented bombing accuracy through reduced defensive interference. The electromagnetic warfare doctrine that had emerged from Joan Curran's laboratory experiments had achieved strategic objectives that conventional bombing tactics had been unable to accomplish. Flight Sergeant Mills completed detailed technical reports documenting window performance across all operational parameters, recording system reliability data that would inform mass production decisions for deployment across bomber command. The Type 91 equipment had exceeded design specifications under combat conditions, operating continuously for 8 hours while generating electromagnetic deceptions that proved indistinguishable from genuine aircraft signatures to German radar operators who lacked countermeasures knowledge. The German response to Hamburg's destruction reflected institutional confusion about defensive failures that could not be explained through conventional tactical analysis. Luftwaffe technical officers initiated investigations into radar equipment reliability, suspecting systematic electronic failures rather than recognizing Allied countermeasures capabilities that had been successfully concealed through operational security measures. The electromagnetic blindness that had enabled Allied bombing success remained invisible to German engineers who approached the problem through equipment malfunction diagnosis rather than enemy innovation assessment. Reichsmarschall Hermann Göring convened emergency meetings with radar technical staff and fighter unit commanders, demanding explanations for defensive failures that had allowed unprecedented Allied bombing accuracy over Germany's most heavily defended industrial target. The briefings that followed revealed institutional inability to comprehend electromagnetic warfare concepts that represented fundamental departure from conventional air defense doctrine based on radar-directed intercepts. Professor Wolfgang Martini, director of Luftwaffe communication research, initiated comprehensive analysis of German radar performance during the Hamburg operations, examining equipment logs and operator reports that documented systematic target tracking failures across multiple installations. His technical investigation would eventually identify Allied countermeasures as the source of defensive degradation, but institutional recognition would require months of analysis, while British bombers continued exploiting electromagnetic advantages that window technology provided. The strategic implications of successful radar countermeasures extended beyond individual bombing operations into comprehensive revision of air warfare doctrine that emphasized electronic systems as decisive factors in tactical effectiveness. Air Marshal Harris received preliminary assessment reports indicating that window deployment had achieved defensive suppression comparable to fighter escort protection while requiring minimal additional aircraft weight or crew training. The electromagnetic weapons that had emerged from British scientific research represented force multiplication capability that enhanced bomber effectiveness through enemy system degradation rather than friendly capability enhancement. Wing Commander Gibson briefed assembled squadron commanders on lessons learned from Hamburg operations, emphasizing Window's effectiveness in degrading German defensive coordination, while maintaining operational simplicity that allowed integration into existing bomber tactics without extensive procedural revision. The radar countermeasures that had proven decisive over Hamburg would become standard equipment across Bomber Command, transforming strategic bombing from costly attrition warfare into systematic degradation of German industrial capacity through electromagnetic dominance. The technical success of window systems during Operation Gomorrah validated electromagnetic warfare principles that would influence air combat development throughout the remainder of World War II, and establish electronic countermeasures as permanent elements of military aviation technology. Joan Curran's laboratory experiments had evolved into strategic weapons that achieved tactical objectives through scientific innovation rather than industrial mass production or conventional military force. The Hamburg Firestorm that resulted from concentrated Allied bombing under window protection would demonstrate the strategic potential of electromagnetic warfare when scientific research translated into operational capabilities that achieved decisive tactical advantage through enemy system corruption rather than friendly system enhancement. German air defences had been defeated not through overwhelming Allied strength, but through British scientific innovation that turned German radar technology into instruments of strategic deception. As news of Hamburg's destruction reached London through intelligence channels and reconnaissance photography, British scientists prepared for expanded window deployment across all strategic bombing operations, while German engineers began desperate attempts to understand defensive failures that threatened the Reich's ability to protect industrial targets from increasingly effective Allied air assault. Joan Curran's electromagnetic deception had achieved what conventional bombing tactics could never accomplish. Window transformed German radar technology into instruments of strategic confusion, proving that scientific innovation could overcome military superiority through systematic corruption of enemy detection systems. The radar trick that began in a cramped laboratory at Malvern would revolutionize aerial warfare, establishing electronic countermeasures as decisive factors in tactical effectiveness. Hamburg burned because British scientists had turned Germany's most sophisticated air defences against themselves through nothing more audacious than precisely timed radio waves.